Okay. So the first thing when you're dividing radical expressions that you want to be aware of is if you have a fraction underneath your radical, like all of it underneath, you can break that up. Like you can put the top underneath the square root and the bottom, like the denominator underneath the square root. So if you have like a fraction underneath a radical, you can always split it up into two separate radicals. And you don't need to necessarily write this, but obviously it works the other way too. If you have two separate radicals, you can combine it as just a single radical. So obviously it works both ways. Kind of repetitive to write it, but um, just so you're clear, because that's going to be really kind of a nice fact for us today. We're going to use this a lot. Um, One thing you want to do when you're solving these, oops, okay, I was just trying to draw a line. One thing when you're solving is you always want to check if you divide like the x over y, like if you plug that in your calculator, and if you plug it in and if it's a whole number, you want to divide it. Because this will make one radical, and we'll see how that works in our problems. But you always want to check, can you divide the two numbers? So, and depending on how it's presented. So I think um, it's probably best if we just get into some examples. But like I said, if it's helpful, you can always break it into two separate radicals, or you can combine it as one radical. But you basically always want to see, can you divide your radicals? Because if you can, you're going to save yourself some work. Because we're going to see basically the idea is we can simplify the top and the bottom separately and then just see if anything simplifies. Or if it divides nicely, you can just divide it and a lot of times save some work or some headaches potentially. So let's look at a few examples. So for problem one, we have the square root of 48 over 3. So if you have a calculator handy, I got my phone right here. You like your first step you should always do, and it's worth the time to do it because like I said, it will and it can save you a lot of time in these questions. Is what is 48 divided by 3? You want to divide that in a calculator. So I just put that in. I know you can't see my calculator screen, but I got 16. So since that's a whole number, we could rewrite this like the square root of 48 over 3 is really the square root of 16. Um, and I don't know if you guys recognize this, but the square root of 16 is a perfect square. That is just 4. But if you didn't recognize that, you could always do your factor tree. Like, but you would see if you did a factor tree, you get two pairs of 2, or 2 times 2 is 4. But I mean, if you recognize that, you didn't have to do that. But our answer would just be 4. Let's look at our second problem. Well, like I said, the first thing you want to check, I mean, you might see it, you might not, but if you try to do 7 divided by 16, you get a decimal in your calculator, or it doesn't simplify very nicely. So if you can't simplify it like into one radical by dividing, you basically want to look at these pieces separately. So you want to see, can you break down the square root of 7? Can you break down the square root of 16? I mean, 7 doesn't break down. So, I mean, it's just going to stay the same. But the square root of 16, I mean, we just did that over here in problem one. I mean, so you don't have to do it again. It is 4. So our final answer would be the square root of 7 over 4. And there's nothing, you always kind of want to double check even when you get this answer, like, is there anything I could do? But there's nothing you can do with the square root of 7 over 4. Like you can't simplify, but you do always want to double check. Sometimes even when you simplify each individual piece, there's still sometimes more you can simplify. We'll see that in a few problems probably coming up. I know at least one I remember from my morning class. But this is kind of like these two problems kind of really illustrate the big idea, though. If you can divide it so you just get one radical to simplify. But if you can't divide it and get a nice number, like you get a decimal, well, then you just want to try and simplify the top by itself and then just try and simplify the bottom by itself. And once you get those two answers, you just put them together, like put your top answer on top, your bottom answer on the bottom kind of thing. But let's look at a few more just so we make sure we've got this down. But like I said, the first thing you always want to do, so for example 3, you want to try and divide that in your calculator. So 125 divided by 5, I know you can't see my screen, I just put that in, I got the square, that would be 25. 125 divided by 5. So now we only have one radical, and I don't know if you recognize this, but the square root of 25 is just 5. So I mean, if you see the answer, if it's one of those special um, perfect squares, I mean, if you recognize the answer, you don't have to do a factor tree. Question 4, try and divide 25 divided by 32. Oops. Let's fix that. But if you plug that in, you're going to get a decimal. I got like 0.78125. You don't get a whole number, essentially. So we need to break down the top and we need to break down the bottom. So usually I just kind of write it below, or if I have like some scrap paper, I just write it on the side. But the square root of 25 is 5. We just saw that in the last question, number 3. But the square root of 32, we could make a factor tree really quick. So 16 and 2, 8 and 2, 4 and 2, 2 and 2, or there's other combinations, but you should see you end up with 1, 2, 3, 4, 5 twos. So you could make a couple pairs. So if you bring out those pairs, 2 times 2 would be 4. And then the only thing left over was one of your twos. So if we write our answer, like the top simplified to 5 and the bottom simplified to 4 over radical 2. And this would be our answer. There's nothing we can simplify. Sometimes you want to check like these coefficients, you might be able to simplify a fraction. And if you're not bad with that, I'll talk about that when we get to a question where we need it. But like, for example, 6 over 2 would be the same thing as 3 over 1. Like if you simplify a fraction, if you have one of those red calculators, it'll do it for you. But I know obviously at home, not all of you guys have access to those, but I'll explain. Like I might post like a website that'll help you if you need to simplify your fractions, because Delta Math sometimes is picky about things like that. Okay, so I wanted to look at a few more examples. And like I said, these notes will be posted on Google Classroom. Like I'll post the key right now. It's just the blank copy as of recording this. But let's just go through a few more examples. Maybe I'll do one, have you try one kind of thing, just so you get a feel for it. But for number 1 on this backside, sorry, like it started numbering again. But we would, since you can't divide 9 divided by 25, like you get a decimal, it's not a whole number. We're going to just simplify each piece. So for example, the square root of 9 over the square root of 25. So we'll just simplify those. I mean, this, if you recognize these are perfect squares, like the square root of 9 is just 3. We already saw this on the other side, but square root of 25 would just be 5. So if we wrote our answer, it would just be 3 over 5. And just be careful, like this was our top, this was our bottom. So just make sure you put them on the right spot. I could see that being a potential mistake, but see if you can try number 2. You're going to see it doesn't simplify, like you can't divide it. So is it not raining? So you're going to want to just figure out quickly what the square root of 4 is, what the square root of 36 is, and then just put it over each other. So I'll give you guys a second if you want to try that one. All right, so hopefully you had a chance to try this, but let's check our answers. So if you break down this 4, I mean, that would just be 2 and 2. So the square root of 4 is really just 2. Square root of 36, if you recognize that, it's 6. It's one of those perfect squares if you know those. But if not, you could do a factor tree. So it'd be not 16. Sorry, 18 and 2. Which would be 9 and 2, which would be 3 and 3. So you would see you get a pair of 3s and a pair of 2s. So 3 times 2 is 6. So if you put these over each other, you would have 2 over 6. But if you know how to simplify fractions, 2 over 6 really does simplify or reduce to 1 over 3. Basically, the idea is you want to figure out a number that divides into the top and bottom. So you could divide the top by 2. You could divide the bottom by 2. But I'll have to see. Sometimes Delta Math is really picky about it. Your answer, it would want you to write it as a simplified fraction. So for example, it might not take the answer 2/6. It might want you to put it in as 1/3. So I'll double check if it is like that. I'll make sure I post, like there are like online calculators that can simplify fractions, as long as you just type them in. So if that is the case, I'll make sure I post one. But let's continue on. Let's look at a few more examples. So number 3, like I said, you always want to take that second. I mean, if you can recognize just by looking, that's awesome. If not, just put in your calculator. But for example, 15/12, if you put that in, you're going to get a decimal or a fraction. So we basically want to treat them separately. So I mean, the weird thing about this question is you can't break down the square root of 15. Like you can't make any pairs, but you can for the square root of 12. You can make a pair of 2's. So this would be 2 square root of 3. So we could write our answer. Like, so the top was this, I couldn't break anything down. So it really is the square root of 15. Like it just doesn't simplify. But the second one would be this 2 square root of 3. This is where a lot of people get messed up though. Like I said, even after you simplify, you want to double check and make sure you can't divide. But for example, now you can divide the square root of 15 by the square root of 3. Like if you put that in your calculator, 15 divided by 3 would be 5. So this would really be the square root of 5/2. Or if it makes more sense, like I'll just write it down here. Like when we broke down the square root of 15, like you could have written that as the square root of 5 times the square root of 3. Basically, those were the two things left over if you kept them separate, over 2 times the square root of 3, like what we got here. And you would see these cancel out. So that's another way you could think about it. You could kind of keep your radical parts potentially separate, but I think a lot of times it might make more sense to see that in hindsight and be like, oh yeah, that makes more sense. But I think if you just remember when you rewrite it, just always double check, even if only one of the parts simplified, see can we divide the radical part now? If you can, do it. If not, leave it separate. But since the square root of 15 and the square root of 3 divides, you could rewrite that as the square root of 5/2. That one is a little bit tricky. Usually that one kind of throws off students. But just remember, you always want to check, like once you rewrite it, like just double check, now can you divide the radicals if you were able to simplify one of them? Because like even though the square root of 15 and 12 we couldn't divide, once we simplify the bottom, 15 and 3 does work. Let's look at number 4 together really quick. So the top, obviously, there's nothing you're going to do with the top, but on the bottom, we could simplify the 2 square root of 20, like if we do a factor tree. We'd see we can pull out another 2, so 2 times the 2 that was already out there would be 4. And then the only thing left over was a 5. So if we rewrite this, we would have 4 in the top, like we're not messing with that. But this 2 square root of 20 we just saw, we could rewrite it as 4 over, wait, what am I doing? Not 4 square root of 5. So you would see your 4's cancel, or since 4 divided by 4 is 1, you would have 1 over the square root of 5. Because 4 divided by 4, you really still have a 1 up top. But you always want to see, can you, like if you have coefficients, you want to see if you can simplify them, or if you have radicals, you always want to check to see if you can divide them as well. Any questions so far? No one said anything in the chat. Oh, there's something. Nope. Okay, well, let's look. Like I said, there are 8 problems. I think I'm just going to do 5 and 6, but I will post 7 and 8 if you want to look at them. I just feel like since we already did 4 in the front, 10 problems should be plenty. But the first thing you want to do is see if you can divide your radical part, like 4 and 5, but I mean, that's not going to give you a whole number. So basically, we want to simplify the top, and we want to simplify the bottom. Square root of 4 is just 2. We've seen that before. This you can't break down, so it really just stays the same. So we could write this as 2 over 4 square root of 5 because we couldn't really do anything with that. Then you just want to double check, can you simplify? Like our coefficient's 2 over 4. If you reduce that, that would be 1 over 2. So you want to see if you can simplify your fractions, but if that's something that does give you issues, like I said, I'll have to see how picky Delta Math is. But I mean, personally, if you left it as 2 over 4, I mean, I would take that answer. But if you are taking a multiple choice test, or if you're typing something into a computer, sometimes they do need the simplified version. They'll be very picky. If it's like a multiple choice test, they're going to put the simplified answer. So hopefully at least you could recognize it, that 2 over 4 is the same as 1 over 2. But it's a very good habit if you can get into, try and simplify it. All right, last question for today. So 6, you can't really divide anything. So you wanted to see, can you simplify either the top or the bottom? But you really can't. Like we can't break down 2, that's prime. We can't break down 5, that's prime. So basically we can't do anything in this problem. I can't simplify like the coefficients. I can't simplify the radical. So this is an example of a question where it's already simplified. So just keep in mind, just because you got a bunch of numbers, like a coefficient and a radical over a coefficient and a radical, doesn't mean it will always simplify. So that's why I threw this question on there. I just wanted you to see, like, I don't know, maybe looking at that, you're like, oh yeah, I bet we can do some stuff with that question, but not always the case. So don't feel bad if you ever get an answer and it's like it just doesn't simplify. That happens. But that is really the idea with division. So 2 big ideas. If you can divide your radical parts, always divide them. It'll make you just have 1 radical versus 2. If you can't do that, well, then you're just going to simplify the top, you're going to simplify the bottom, and then just put them back together. So that's really how division works.